JudgeLM, fine-tuned large language models, are scalable judges. Evaluating large language models, LLMs, in open-ended scenarios is challenging because existing benchmarks and metrics cannot measure them comprehensively. To address this problem, we propose to fine-tune LLMs as scalable judges, JudgeLM, to evaluate LLMs efficiently and effectively in open-ended benchmarks. We first propose a comprehensive, large-scale, high-quality dataset containing task seeds, LLMs-generated answers, and GPT-4-generated judgments for fine-tuning high-performance judges, as well as a new benchmark for evaluating the judges. We train JudgeLM at different scales from 7B, 13B to 33B parameters, and conduct a systematic analysis of its capabilities and behaviors. We then analyze the key biases in fine-tuning LLM as a judge and consider them as position bias, knowledge bias, and format bias. To address these issues, JudgeLM introduces a bag of techniques including swap augmentation, reference support, and reference drop, which clearly enhance the judge's performance. JudgeLM obtains the state-of-the-art judge performance on both the existing Pandalum benchmark and our proposed new benchmark. Our JudgeLM is efficient, and the JudgeLM 7B only needs 3 minutes to judge 5K samples with 8A 100 GPUs. JudgeLM obtains high agreement with the teacher judge, achieving an agreement exceeding 90% that even surpasses human-to-human agreement. JudgeLM also demonstrates extended capabilities in being judges of the single answer, multimodal models, multiple answers, and multi-turn chat. HyperFields towards zero-shot generation of NeRFs from text. We introduce HyperFields, a method for generating text-conditioned neural radiance fields, NeRFs, with a single forward pass, and optionally some fine-tuning. Key to our approach are a dynamic hypernetwork, which learns a smooth mapping from text token embeddings to the space of NeRFs. 2. NeRF distillation training, which distills scenes encoded in individual NeRFs into one dynamic hypernetwork. These techniques enable a single network to fit over 100 unique scenes. We further demonstrate that HyperFields learns a more general map between text and NeRFs, and consequently is capable of predicting novel in-distribution and out-of-distribution scenes, either zero-shot or with a few fine-tuning steps. Fine-tuning HyperFields benefits from accelerated convergence thanks to the learned general map, and is capable of synthesizing novel scenes 5 to 10 times faster than existing neural optimization-based methods. Our ablation experiments show that both the dynamic architecture and NeRF distillation are critical to the expressivity of HyperFields. Deja vu, contextual sparsity for efficient LLMs at inference time. Large language models, LLMs, with hundreds of billions of parameters have sparked a new wave of exciting AI applications. However, they are computationally expensive at inference time. Sparsity is a natural approach to reduce this cost, but existing methods either require costly retraining, have to forego LLM's in-context learning ability, or do not yield wall clock time speedup on modern hardware. We hypothesize that contextual sparsity, which are small input-dependent sets of attention heads and MLP parameters that yield approximately the same output as the dense model for a given input, can address these issues. We show that contextual sparsity exists, that it can be accurately predicted, and that we can exploit it to speed up LLM inference in wall clock time without compromising LLM's quality or in-context learning ability. Based on these insights, we propose Deja vu, a system that uses a low-cost algorithm to predict contextual sparsity on the fly given inputs to each layer, along with an asynchronous and hardware-aware implementation that speeds up LLM inference. We validate that Deja vu can reduce the inference latency of OPT 175B by over 2x compared to the state-of-the-art faster transformer, and over 6x compared to the widely used Hugging Face implementation, without compromising model quality. The code is available at the project's website. Controlled decoding from language models. We propose controlled decoding, CD, a novel off-policy reinforcement learning method to control the autoregressive generation from language models towards high-reward outcomes. CD solves an off-policy reinforcement learning problem through a value function for the reward, which we call a prefix scorer. The prefix scorer is used at inference time to steer the generation towards higher reward outcomes. We show that the prefix scorer may be trained on possibly off-policy data to predict the expected reward when decoding is continued from a partially decoded response. We empirically demonstrate that CD is effective as a control mechanism on Reddit conversations corpus. We also show that the modularity of the design of CD makes it possible to control for multiple rewards, effectively solving a multi-objective reinforcement learning problem with no additional complexity. Finally, we show that CD can be applied in a novel blockwise fashion at inference time, again without the need for any training time changes, essentially bridging the gap between the popular best-of-K strategy and token-level reinforcement learning. This makes CD a promising approach for alignment of language models.